Day 584 of doing a LeetCode problem every day until I like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. An example one, or excuse me, a squared triple, sorry y'all, a squared triple ABC is a triple where A, B, and C are integers and A squared plus B squared equals C squared. Given an integer n, return the number of squared triples such that 1 is less than or equal to A, B, and C is less than or equal to n. All right, y'all, so that may seem a little bit confusing. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example one, we have our input n equals 5. Our output is equal to 2. Explanation says the squared triples are 3, 4, and 5, and 4, 3, and 5. So as we can see, right, if we do 3 squared, let's say 3 squared, that equals 9. Boom. Then we do 4 squared. Hold on just a minute, y'all. 4 squared, that equals 16. Boom. And then we do 5 squared. That equals 25. Boom. Now, as we can see, 3 would be A, or in this case, so now that we have the squares, in this case, it would be 3 would be A, B would be 4, and 5 would be C. So it would be 9, which is 3 squared, plus 16, which is 4 squared, equals 25, which is 5 squared. So that's our first triple right here. Boom. Then as you can see for the second triple, all they did is swap these two numbers. So we just did 16 plus 9, that equals 25 as well. So just so you know, this is where we get into 9, 16, and 25. This is 3 squared, this is 4 squared, this is 5 squared, and then this is 4 squared, this is 3 squared, and this is 5 squared. In total, we have 2 triples, so that's why we return 2. Now, just in case that didn't make sense to y'all, let's take a look at example 2. Example 2, same principles apply. So in example 2, we have n equals 10. This time the output is 4. The triples are 3, 4, and 5. So let me just bring that back then. Might as well bring that back over here. So we have 3, 4, and 5. Boom. Then we have 4, 3, and 5. Then we have 6, 8, and 10. So 6 squared is going to equal 36. Boom. Then 8 squared is going to equal 48, I believe. So hold on, 48. Let me put this. Boom. Oh no, 8 squared equals 48. Hopefully my math's not off, but if it is, I'm sure we'll find out soon. So let's see. Then 10 squared is equal to 100. So hold on, 10 squared equals 100. Boom. So no, this is not 48. This would be, one moment, y'all. My brain is going blank right now. Oh yeah, no, I'm sorry. This would be 64. I'm tripping, y'all. Sorry about that. 8 times 8 is 64. Excuse my math. Just waking up, a little foggy right now. So boom. 8 times 8, 64. 6 times 2, 36. 36 plus 64 is going to equal 100. So boom. Let me see. So yeah, it's the same thing. So it would be 9 plus 4 again is going to equal 25. So once again, we do the same thing. Then would be 4, or not 4, but 16. Then 16 plus 9. That's going to equal 25. Boom. Then once again, we'll do 36 plus 64. That's going to equal 100. And similar to this, 64 plus 36. That's going to equal 100 as well. So these are just our math, making sure everything is correct. So first two tuples are 3, 4, and 5. We get those right here. Boom. You will see that the requirements work out with 3, 4, and 5, as well as 4, 3, and 5. And same with 6, 8, and 10, and 8, 6, and 10. You can see those requirements work out as well. Boom. So, and in total, for example 2, there were 4 of these. We had 6 and 8, or 8, 6, and 10, and 6, 8, and 10. And then we had 3, 4, and 5, and 4, 3, and 5. We got these numbers from right here and right here. And yeah, y'all, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, y'all. So let's get into it. Now, the first thing we are going to do is we're going to check if n is 1 or less. It's impossible to form a valid triple, so we'll return 0 immediately. So we're just going to say guard n is greater than 1, else we're going to open up the brackets and we're going to return 0. Boom. Then we need a place to store the result of the total number of valid triples found. So we could say var result. We could set that equal to 0. Boom. Now we need a loop from 1. We need a loop I from 1 to n minus 1, and I is always less than j to avoid counting duplicates in this loop. So we're going to say for I n 1 dot 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 n minus 1, we're going to open up the brackets. Then we're going to loop j from I plus 1 up to n, and this is going to ensure that, or j being greater than I ensures that eliminating reverse duplicates like j and I. So we're just going to say for j and I plus 1, then we're going to, I plus 1 up to n, sorry y'all, up to dot 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 n, boom. Then we're going to open up the brackets and we're going to come right here, boom. Then we're going to compute I squared plus j squared, and this represents k squared in the Pythagorean triple or theorem. Since square root returns a double, k is stored as a double for comparison. So we're just going to say let k equals going to be a double. Open up the parentheses, we're going to say I times I plus j times j. Boom. Now we're going to check two conditions. The square root k is an integer, which means I squared plus j squared is a perfect square. And then the integer k value is less than or equal to n, and k must be within the allowed range. So we'll come right here underneath this, and we will say if square root, or sqrt, open up the parentheses, k, come outside of those parentheses, equals a double, open up the parentheses, we're going to pass in an integer, open up the parentheses again, we're going to say sqrt, open up some more parentheses, pass in k, come outside of those parentheses, we're going to say and, two and signs, and open up the parentheses, we're going to say sqrt, open up some more parentheses, pass in k, come outside of that, we're going to say less than or equal to n, boom, we're going to open up the brackets, and the valid triple found, so we're going to increment the count by saying result plus equals 1. Then finally, we're going to multiply the result by 2 for every I, j, k pair, because as you can see, each pair will count as 2, right? Because we could just flip them. So we need to make sure we multiply the result by 2 for that, just in case so we can return them in reverse order. So we could just say return result times 2. Boom, y'all, that should be all she wrote. Let's give it a run, make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it, because we all know how LeetCode can be. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.